Hi, my name's Terry, and today we would like to share with you our unknown hormone project. Our group name is Out of Balance, and we were assigned code 737. The main objective of the project is to determine the unknown hormone that was administered to our experimental rat. This slide shows the data we were provided for the rats in both the control and experimental groups. The rats in each group were treated for 10 days. The control group was administered saline, while the experimental group received the unknown hormone. Administration occurred between 1 and 4 times daily. Using the data provided, we performed significance tests. This allowed us to identify any statistical differences that we needed to research further. This graph contains data for the glucose tolerance test performed on both groups of rats. The data for control rats is in black, while the red represents the experimental rat data. The test was performed over a 3-hour period of time. After administering glucose to the rats, their blood sugar levels were recorded in the time increments shown on the graph. You can see there was a slight elevation in the blood glucose levels of the experimental rats. However, the increase is not statistically significant. It also is a controlled increase, as it rises and falls at the same intervals as the control group. Using the data provided for each group of rats and the results of the significance tests we performed, we determined the following had no significant change: the mass of the adrenals, the mass of the thyroid, the iodine uptake of the thyroid, the mass of the pituitary, mass of the testes, the free fatty acid plasma levels, and the blood glucose levels. Our significance tests and the data showed a significant increase in the mass of the seminal vesicle, mass of the prostate, the tibia width, mass of the ovaries, mass of the uterus, which was also identified as pale in the data, as well as body weight gain, while the mass of the thymus showed significant decrease.
So we had a list of possible hormones that it could be and that we could choose from. So I'm just going to list all the possible hormones. So there was TSH, thyroxine, glucocorticoid, ACTH, growth hormone, somatostatin, HCG, testosterone, estradiol, epinephrine, and placebo. So these were some of the hormones that we rolled out. So we have TSH and thyroxine, which both of them had no significant difference between the experimental and control data. So we knew right off the bat that they both were not our hormone. And then going into placebo, placebo would have no effect on the experimental rats, but there were significant changes among some of the data that we did have. And then lastly, somatostatin. The administration of somatostatin would provide neuroendocrine inhibitory effects. These are not observed as data shows increase in tissue mass. So these were some of the other hormones that we rolled out as well. So we have glucocorticoid, which administration would cause an increase in blood sugar and plasma FFA, which neither was not observed in data. So going into epinephrine, administration would cause the increase in glucose levels, which was not observed as well in our data. And then the ACG would present or indicate pregnancy. So the experimental rats displayed a pale uterus, so it's indicating a lack of blood flow and would be contradictory to the blood flow in the uterus during pregnancy. And then lastly, we have ACTH, which would cause an increase in cortisol and also increase in body weight and glucose levels. You would see that. So the slight elevation was seen in experimental rats, it was not significant as to ACH was administered. These were the three hormones that we narrowed it down to and that were in question. So we had growth hormone, testosterone, and estradiol. The tests that we thought to request for were the vital signs, because we thought that the vital signs would really tell us a lot about the rats, and the use of what hormone it was. And then after that, we decided to do an RIA plasma test for testosterone.
So for the vital signs results, we had two separate categories. We had control and experimental. So for the heart rate, for the control, we had 110 beats per minute. And for experimental, we had 120 beats per minute. Respirations, we had 42 breaths per minute for the control and 50 breaths per minute for the experimental. The body temperature for the control was 39.7 degrees, and for the experimental, it was 45.3 degrees. And for blood pressure, we had 70 over 100 for the control, and then for experimental, we had 199 over 109. Based on all these results, we kind of got more closer to our conclusion and kind of ruled out some of the other hormones based on things that they can do to your body and some things that other ones can't do. For the radioimmunoassay plasma results for testosterone, we did this test kind of to get a more overall idea about testosterone and if it was actually the hormone that we were going to stick with. For the control, it was 4,121 plus or minus 391 CPM. And for experimental, it was 1,051 plus or minus 215 CPM. So starting with estradiol, we originally had this as one of the possibilities, but after looking at the vital signs, we were able to rule it out just because it would not have caused an increase in the body temperature as well as heart rate. Now we move on to why it's not growth hormone, which was also one of the original ones that we kind of thought from the beginning, but after seeing our test results, it'll typically decrease arterial blood pressure, but it increased, and it also does not usually cause an increase in heart rate, which also happened. So after seeing all of the tests done and looking over all of our results, we came to the conclusion that based on everything, we think that the hormone administered to our control rats is testosterone.
The increase in vitals is explained by the administration of testosterone. Review of the RIA plasma testosterone results confirms testosterone administration as well. Research provides us with data that suggests castration of rats led to a strong increase in thymus activity. Conversely, administration of additional testosterone led to apoptosis of thymic cells. This accounts for the decrease in thymus mass. The tibia width increase is explained by research showing correlation in testosterone administration and increase in epiphyseal growth plate. Excess testosterone can lead to polycystic ovary syndrome, as well as uterine fibroids and endometrial growth. These would contribute to the increase in organ size as well as restrict blood flow to the uterus, causing it to be pale. Increase in prostate mass is consistent with administration of testosterone. Similar results are seen in the seminal vesicle.